Hello and welcome to a new video on YouTube channel of tutorialspedia.com. In this video, I'll talk about microservices architecture and I'll be primarily focusing on the beginners with a basic understanding of microservices architecture. And I'll be explaining the transition from conventional monolithic to microservices architecture. Let's have a look at the concepts and the topics that we are going to cover in this video tutorial. First of all, we will see a high-level overview of microservices architecture, where I will explain what exactly is microservices architecture and why we need microservices architecture. Then I will talk about a bit about conventional monolithic architecture. We will have an overview of monolithic architecture, and I will explain the basics associated with monolithic architecture. And last but not least, we will talk about a comparison between monolithic and microservices architecture, and I will shed a light on some of the positivities and benefits associated with the microservice architecture that will set a ground for the reasons to choose microservice architecture compared to the typical monolithic architecture. Please note that in this video I'll not be going into the nitty-gritties and much of the technicalities, as I explained that I'm focusing mainly on the beginners who don't have much knowledge about the microservices architecture, and by going through this video you should have fairly good knowledge at the end of this video about the basic concepts associated with microservices architecture. So if we talk about microservices architecture and microservices in general, and we have an overview of this, basically microservices architecture is a collection of loosely coupled, independently deployable fine-grained services. What happens in case of microservices architecture is that we go at the micro level, which means that based on the business capabilities and the business requirements, we try to break the bigger picture into the smaller pieces. And we want to make sure while we are constructing the microservices through microservices architecture that the services that we define and deploy, those are loosely coupled and they are not too much interdependent, and then we make sure that they are independently deployable. So that's the beauty of microservices architecture, that once you have separated your services, and once you have drilled down and created separate deployable artifacts for different microservices, then you have an independence, and you have convenience to deploy them independently without affecting much of the work related to the other services. And they are fine-grained services. When we say these services, the microservices are fine-grained services, this means that they are at a fine granular level, and you don't have to consider them as a fat typical application. Rather, those will be smaller applications. Most of the time they will be focusing on some specific type of requirements, and underneath in many cases you will be going with a separate database and separate layers associated with those. So in this way you make sure that the services that you define through microservices architecture are at a fine-grained level, and you have liberty and you have the independence to handle those services without having much of the dependencies between these services. And as I stated, in case of microservices architecture, the services that we define and design, they are based on the business capabilities. So what happens is that when you have a business requirement, often you come across a high-level business requirement, and when you drill it down and when you break it into the pieces, you come across multiple sub requirements or sub services that you can make out of it. So this is how you define your microservices based on the business capabilities. Take an example of a shopping cart. When in case of an e-commerce application or an e-commerce web service, web application, you have multiple business capabilities as part of that web application. And in that case you have different requirements and you have different functionalities, like you have requirements for the user management, for the user registration, for user authentication, for the product catalog, for the product selection, for the cart handling, for the payments, for the cancellations, and so forth, so on and so forth. So depending on the requirements, you drill down and you decide that which of these services can be separated. And in that way, you come across with the microservices based on your full-fledged requirement. And for individual requirements, once you have designed your microservices, then you can plug and play those services, and you can create composite services out of those microservices, and you can fulfill your requirements by having, maybe you can think of having an API gateway on top of those services that are the backend microservices. So depending on your requirements, depending upon your scenarios, you can decide how many microservices you need for a specific scenario, and then you have to ensure that the microservices that you are defining, they are independently deployable, and they are loosely coupled, and they are fine-grained to a certain level. Now that we have talked about the basic overview of microservices, we need to understand and we need to set a ground that why we need microservices. So before we set a ground for the microservices and we convince ourselves that we need microservices, we first need to look at the conventional monolithic architecture, because you need to understand the problem, and only then you need to come to the solution. So we will first look at the monolithic architecture, and then we will try to find out that what are the reasons and what are the scenarios and what are the complications that are associated with this conventional monolithic architecture, which forces us or which convinces us to switch towards the microservices architecture. So if we talk about monolithic architecture, what exactly a monolithic architecture? In case of monolithic architecture, you have one box for all the tools. This means that what happens is that you have a fat application with all the functionalities clubbed together. So in a typical application, you have UI or front end layer, you have business logic layer, you have data access layer, and you have a backend database which is persisting your data. So you might have MVC architecture, and you can have multiple tiers, multiple layers depending on your scenarios or your application requirement. But in general, what happens is that all of these layers, they're clubbed together in the form of a single application, and depending on your programming language or whatever technologies you are using, all of them majorly in the same set of technologies being implemented. For example, no matter how many different modules, or no matter how many different pages or front end screens you have created, typically what happens is that you choose one particular front end technology, and you implement all of those. Same goes for the business logic. So behind the scene, if you're using any of the plugins, or if you're using any specific programming language, normally what happens is that you build or you implement all of that business logic in the same programming language with a similar approach. For example, maybe you will be implementing everything with Java, with Java Enterprise Edition, with JPA for the persistence, and in the backend you will be having one of particular database. Maybe you have Oracle database, or maybe you have SQL database. And what happens is that you follow the same pattern for all of the modules or all of the components that you have for that application. And once you have implemented that application, then if you have to deploy that, what happens is that you create one deployable artifact in the form of a WAR file or ER file or whatever it is, and then you deploy it, and all of the application gets deployed. So this is for a typical monolithic architecture where everything is clubbed together in the form of a single box. Of course, when we deploy it, we can do the horizontal scaling and even vertical scaling as well. But what happens is that everything is considered as a single box, or the entire application is deployed as a single unit. Now let's talk about the problems with this monolithic architecture. And this, once we understand these problems, only then we will be convinced to go for another improved or enhanced or more modern architecture, that is microservices architecture. So the first problem that we see with this monolithic architecture that I just explained is that you have a complex application. And when we have a complex application, it's always hard to change its scale. What happens is that, as I explained, that you create one big fat application, and you club together everything. You select the technology, you select the tools, and then once you have implemented that complete solution and you have deployed it, if you have to change it, then there is a problem. The problem is that you need to make sure that whatever changes that you make, they don't impact or affect the other implementations or other functionalities that are part of your application. And also the scalability becomes a major problem in this scenario. What happens is that if you have to if you have multiple functionalities as part of your application, let's suppose one of the search functionality needs to be scaled up because you observe that your customers or your clients are making too many searches, but the problem is that the whole application is clubbed together. So if you have to scale the entire application and not the single piece. So in this case, you will need more resources. You will need, even if you have to scale it horizontally or if you have to scale it vertically, in either case, you will need more resources and more complexities will be associated with this. So this is one of the major problems that is associated with this conventional monolithic architecture. The second problem that we foresee and we observe with this monolithic architecture is that deployment becomes another complexity for you to consider, and it's difficult to go with the continuous deployment. And what happens is that since everything and all of the functionalities, be it at the UI level, at a business layer, or at the persistence layer, or at any layer, all of them are part of the same fat application. So if you have to deploy, you have to deploy the whole. You cannot go with the deployment of some specific set of features out of it. And even if you go with the CI/CD approach, there are situations where you come across problems. Some of the functionalities get broken because of uh, some of the dependencies that might not be understandable for you at the time when you are designing the application, and you come across that many hooks and many of the integrations between the components within that flat application get affected just because you made some changes and deployed in some of the parts of your application. So overall, it becomes a problem and a mess when you are doing the deployments for this type of a monolithic architecture-based application. The third problem that we see and observe for this monolithic architecture is the resistance to architectural and technology stack changes. So basically, when we are implementing an application or a solution based on the requirements that we have from the business, we initially select some technologies and we select the tools, and we come across the complete set of technology stack. For example, maybe you decide that you will go with the Java for the implementation. For the front end, you will be using some of the extensions and some of the UI plugins or modules. And for the backend, also you decide that you will be going with some specific database. For example, you will be going with Postgres or you will be going with Oracle. So what happens is that in the later stages, once your application is mature and it's deployed and it's running, then you find out some of the maybe you find some of the security issues, maybe you find some of the performance issues, UI related, aesthetic related issues, or anything that you need to improve or you need to change, and you need to update your application to the latest trends and latest technologies that are available in the market. Then it becomes really difficult because you have to go back to square one. You have to reinvent the wheel. You have to make changes to each and every part of the application because this is one application deployed as a single application, and you cannot make the changes at the individual level. You have to make the decision and you have to make the changes for the entire application. And with this type of monolithic architecture based application, it becomes difficult and you have a resistance from within your teams, from within your organizations, because if something is running, people consider it okay and they don't want to change it. But sometimes you have a need to change it. But if you have a monolithic architecture, then such changes and such type of architectural and technology stack level changes might have higher impacts and severe consequences as well if you did not do proper R&D and if proper testing is not done. The next problem that we see with this monolithic architecture is that it has certain performance implications. So what happens in this case is that you have a bigger database because you have an underneath database to which all of your layers of your big fat application are integrated. And what happens is that no matter how much tuning you have done to the database, you come across the performance implications in terms of deadlocks, in terms of logs, in terms of the slowness, higher response time, lower throughputs. So all these type of problems come across when with the time and with the growth of the data that is being handled by your application, and not only at the database level but also at your business logic level and at the UI level also. You might observe that you have certain glitches, you have certain performance and UI issues. This is all because everything is clubbed together in the form of one application, and it's always hard to tune it and improve when everything is tightly coupled. So, based on all the problems that we have just come across and we have observed for the conventional monolithic architecture, the solution and the answer to all the problem is to switch toward the microservices. So, microservices architecture that we will talk now, this is the solution to mitigate, to avoid the problems that are associated with this monolithic architecture. So let's talk about some of the salient features and the pros that are associated with microservices architecture, which force us or which convince us to switch from the monolithic to the microservices architecture. The first thing is the function separation. What happens in case of microservices architecture is that, as I explained before, that based on your business capabilities, you define your microservices. And what happens is that you don't put everything in a single box. Depending on your requirements, you decide that which of these services can be separated and considered as individual piece. So in that way, you define multiple microservices, and those are revolving around certain business capabilities. Like if you have a certain HR system, within HR system, you will have separate microservices dealing with the employees' data, separate services for payroll, separate service microservices for handling the transition of the employees from one department to another. You might have various other microservices related to the other HR related operations for onboarding, for determination, for the appraisals, etc. So name it anything depending on your requirements. You might have tons of microservices, and all of those services will be revolving around certain business capabilities or business requirements. The second positive aspect of microservices is that you have greater scalability. As I was explaining that in case of monolithic architecture, scalability also becomes a major concern with one single monolithic fat application. But here in this case, since you have separated your requirement and your services in the form of microservices, so now if you have to go for a horizontal or vertical scaling, this is at your own convenience. Let's suppose that you have 10 microservices, and one of the microservices out of those 10 services is dealing with the user registration, and you have you come across the scenarios that you have a lot of user registrations coming in at some specific season during the year. So what you can do is that you can simply do the scalability. You can simply consider that particular microservice service for the scalability, and you can add multiple additional resources for the additional resources, and you can have additional deployments for the same service. And in that way, you can have vertical as well as horizontal scaling of your application. You can always scale it up. You can always scale it down. If you think that certain microservice is getting underutilizing the resources because you have put too many resources, you can always scale it down as well and utilize those resources for some other services. So you have your own convenience, and you have flexibility to scale it up and scale it down. Another positive aspect for the microservices is that you have a better control. How you have a better control? Because contrary to the monolithic architecture, now you have ease of deployment. As you are handling all of the services separately in the form of microservices, so any of the microservice, you can always think of it as a single piece, and you can deploy it, you can undeploy it, you can make the changes, and also if you have to handle any issues, you can handle it separately. So once you have uh, this will result into a little plug and play type of situation for you in your organization. And if you have to do the redeployments, you have to do host deployments, if you have to do hot deployments, if you have to make any changes and you have to revert anything, you are not going to revert, you are not going to deploy, undeploy, or make any changes to the entire set of services. Rather, you are focusing on a single service. And another way you will have a better control is that now, since you have separate services based on different business capabilities, you will have separate teams or separate resources within your organization handling these different microservices. So if a particular team or a set of resources within a team is handling a particular microservice, then they have full control, they have full visibility, they have full understanding of that particular microservice, and they will be in a better position to handle the issues separately for that. Contrary to the monolithic, where if you have to understand a problem, you will have to look into the entire code, you will have to look into the entire application, and even after that, you will not know that some specific changes who is responsible within the team. Of course, you can track it down based on the version control systems and based on the tracking that who has committed those changes. But in either case, this becomes a mess. But in case of microservices, this becomes quite easier to handle within the teams as well. And the next positive thing is that you have an increased productivity. As I stated in previous case, in case of monolithic, it's always difficult to adapt to the technology changes, to the technology stack selection once you have a mature application already running. And any changes or enhancements are also difficult, and you have a resistance within the team and within the organization. But in case of microservices, since you are handling these services or these capabilities separately, you have a convenience to adapt and change and enhance. It's beyond the technology limitations as well. Maybe you have one microservice that has been that is in the form of some APIs or services deployed and implemented in .NET. You might have another microservice which is in Java, and you might have another one in some other, maybe in PHP or in some other programming language. So you have ease to adapt, and whenever you have to make some changes in terms of the technology stack, you will be able to make those changes quite conveniently. The next positive point that I'll talk about is that you have fine-grained fault tolerance. So contrary to monolithic, where you have to do the fault tolerance at the entire application level, here in case of microservice-based architecture, you will have your fault tolerance implemented at individual service level. So in this way, depending on your requirements or depending on your business model, you will be going at any level that, for example, maybe in some business critical or maybe some financial or some other related applications which are critical in nature, you will have a higher level of fault tolerance, and you will be dealing those errors and faults in a separate way. And maybe you have some other time critical applications for which the time and the response time is the major concern. In that case, you will be handling it separately, and you will be doing it in a way that those responses are not impacted just because of excessive fault tolerance. So all this decision related to fault tolerance will be at the individual microservice level. So that's it from this video, and I hope that the information that I have conveyed to you through this video will be helpful for you. Of course, I didn't go into much of the nitty-gritties and technical details specific to each topic, as the microservice architecture and the terms and the technologies and the concepts that are associated with this microservice architecture are quite huge. So I cannot cover all of those in one video, but I tried my best to focus on the basics, keeping in mind the beginners as this video is focused on the beginners. So if you have any questions, or if you have any doubts, you can always write in the comment section. I'll try my best to respond to your questions and to clarify if you have any doubts. You can always refer to my website tutorialspedia.com if you need any further assistance, and if you want to read further about related topics, as we have tons of videos and other articles on the website. That's it from this video, and if you like this video, please don't forget to subscribe to the channel and press the bell icon. Thank you very much.